Hello students, we are in numerical 17, exercise problem 17 of chapter 7 in this video. The question is, keeping the source frequency equal to resonating frequency of the series LCR circuit, if the three elements L, C and R are arranged in parallel, show that the total current in the parallel LCR circuit is minimum at this frequency. Obtain the current RMS value in the branch of circuit for the elements and source specified in exercise problem 7.11 for this frequency. So let us first have a look at exercise problem 7.11 and then we will come back to this problem. Here is 7.11 and as we can see here, all the three components are connected in series. Now we have the same component, same source, but the three are to be connected in parallel. So let us go back to the current problem and I will fetch this data also there. So here is the data of 7.11 and the circuit which we are talking about is parallel combination of LCR connected to a source of alternating voltage with the values voltage and parameter values given here. So for this circuit, if we want to find out current, we don't know how much is the impedance. So better way is to go for Coulomb's second law. We know that if current here is I, and if I denote current here as IR, IL, and let the current here be IC, then phasor method, if I add up, because the phases of these currents are not same, so I cannot directly apply Coulomb's second law or Coulomb's first law. So IR plus IL plus IC we cannot do because phase difference is not same, phases are not same. So what we can do is, we know that phasor of current passing through resistance, if it is taken as reference, the current in let me put it again. So if this is the phasor of current passing through resistor, and if we take this one as current passing through capacitor, let this be current passing through inductor, because current passing through capacitor is leading the voltage by 90 degree, whereas current passing through inductor is lagging behind by 90 degree. So overall phase difference between current passing through capacitor and inductor is 180 degree as shown here. So resultant of the IC and IL, if we assume that IL is more than IC, then the resultant can be shown like this. This is IR and let this be IL minus IC, and then I can say that this is the resultant current in the circuit. So that can be given as I square is equal to IR square plus IL minus IC whole square. We are assuming here that IL is more than IC. So that is V square by R square plus V by XL minus V by XC whole square, or else it can be written as V square 1 by R square plus 1 by XL minus 1 by XC whole square. So if I compare this with I square is equal to V square by mod Z square, then what I have here, this bracket is equivalent to 1 by
mod z whole square, and then I can say that 1 by mod z whole square is 1 by r square plus 1 by xl minus 1 by xc whole square. So 1 by mod z is nothing but under root of 1 by r square plus I am substituting xl value, which is omega L, and xc is 1 by omega c. 1 by xc will be omega c. So this is what we get as mod z. Now look at this equation once again. During resonance, we have omega L equal to 1 by omega c. So if I consider uh, the source frequency and resonance frequency to be same, what I am talking about is 1 by omega L and 1 by omega c to be equal. Okay, and in that case, if this condition is satisfied, the 1 by mod z square will be reduced down, not square, 1 by mod z will be reduced down to 1 by r. And so if you eliminate this term, so in that case what happens is we are losing this value. We are losing this value if 1 by omega L is equal to omega c, or omega L is 1 by omega c, and then the overall term is reduced. But as the left side is 1 by mod z, we can say that z value will increase. Okay, and if z value increases, current value will decrease. So we can say that if this condition is to be satisfied for this particular circuit, sorry, for this particular circuit where L, C and R are connected in parallel, then Z value will be minimum, sorry, Z value will be maximum and current will be minimum. So this is how we can show that. Now as far as the current passing through each branch is concerned, we can find out current passing through resistor with the formula V by R, current passing through inductor with V by XL, or V by omega L, and IC with V by XC, or V by 1 by omega C, or you can say V into omega C, which we are talking about. All this V are RMS value of voltage, okay, which we are given 230 volt. So that is all about problem 7.17. Thank you.